Hi, geometry students. We are going to be working on section 1 from chapter 14 in this Zoom recording. Okay, so let me share from my screen. When you get ready to study the chapter from the book, be sure to take a look at all of the vocabulary. This gives you a good sense of what you need to make sure that you have learned for this chapter. But to start off with, this is on three-dimensional figures and cross sections. So the first thing that we need to make sure that you remember from your previous study of geometry or that you learn now are some vocabulary. So I'm not going to draw these for you because it's much simpler just to show it to you in the book. You need to know each of these. So prisms are named for their bases. So a prism has two bases that are connected with rectangles, right? So a triangular prism has two triangles for its bases, and then it is connected by lateral faces that are rectangles. Rectangular prisms, this can be defined, its bases could be defined as the front and the back, or the two sides, or the top and the bottom. Any of those could be the bases on a rectangular prism because the bases and the lateral faces are the same. A cylinder has circles for its bases, and it has two bases. A cone has only one base and comes to a point at the top. A pyramid has one base and is also typically named for its base. So in this case, this is just showing you an example of a pyramid. I would probably have called this a square pyramid. And then a sphere is a three-dimensional shape formed by the rotation of a circle. Okay, polyhedrons. So a polyhedron, poly means many, hedron means face. So a polyhedron is a three-dimensional figure that has many faces. Vocabulary that you need to know. We have our faces. The edges are the segments that are formed by the intersection of two faces. And a vertex is a point where three or more edges intersect. The vertex is the intersection of edges. The edges are the intersections of the faces. Okay? All right. Another thing that you need to know, and at this point, after we look at this key concept, I'm going to start writing on my paper, is Euler's formula. Euler's formula was derived by Euler. Notice it's spelled E-U-L-E-R, but it's pronounced like oil. Euler's formula. Three-dimensional figures are formed. The formula is the number of faces plus the number of vertices is equal to the edges plus 2. Now, if we were doing this in class, we probably would do an exploration where I had you count these on several different polygons and discover this was true for yourself. For our purposes, I'm just going to give you the formula this time. In 2 dimensions, so that means if we take a 3-dimensional figure and we draw its net, Euler's formula becomes faces plus vertices equals edges plus 1. Now, my preference is the 3-dimensional. That's the one that you typically see and that you usually use in geometry. Okay, so problem number 1, using Euler's formula. So chapter 14.1, get my pen. I am going to sketch a hexagonal prism on my page. When I sketch prisms, I do my first base, and then off down and to the side, I do the next one. And then I connect each of the vertices. This one, I think I am not very happy with the way that I drew that one. Okay, now sometimes the process of drawing actually can help you with counting things. So first we count the number of faces. We have the 2 bases, so that's 2. Plus each of the faces that comes up from the side is going to be 6, because we have 6 sides on our bases, so that's 8. Then we want to look at the number of vertices. The number of vertices is, on one base, I have 6 on the bottom. 1, 2, 3, 4, 5, 6, and I have the same amount on the top. So I have 6 vertices on the top and 6 on the bottom base. And so I have a total of 12 vertices. Now, the total number of edges, those are going to be the segments where the faces intersect. The number of edges is going to be each of these segments along the lateral faces. So there'll be 6 of those. And then each of the segments going around the edges at the bottom, that's going to be 6, and then 6 also at the bottom on the other base. So 18. So now let's check Euler's formula. Euler's formula says that vertices and faces, or faces plus vertices, is going to be equal to the number of edges plus 2. So we have 8 plus 12. Does that equal 18 plus 2? 20 equals 20. Yes, it does. So typically the way that you use this formula is you might be given the number of faces and vertices and be asked to figure out the number of edges, or given 2 of the 3 variables and asked to solve for the others. It's once you get into many-sided figures, it's definitely more straightforward and easier to use the formula than to try to count them all yourself. Okay, the next thing I want to talk about is describing that was problem 1, is describing a cross-section. So that's problem 3 in your book. So one of the things that you need to be able to visualize is what would happen if you had a 3D figure that you took a plane, put that plane through the figure. This is where, if you are a video game player, you have been helped. Video games help with geometry because it's actually easier for people who play video games to look at 2-dimensional, just statistically speaking, 2-dimensional figures and be able to understand conceptually what's going on with them in 3 dimensions. So if I were to take a cylinder and to put a plane through that. So if I were to do a cross section through the cylinder, right through the very middle of it, what shape would I get in that cross section? So essentially, what have I got going on right here? Well, if you're thinking a rectangle, you're right. Now, drawing a cross section. Drawing a cross section is an interesting skill. Okay, so drawing a cross section using a cube. So we're going to start with 2 squares lined up like so. Okay, if I wanted to do a cross section that went through one corner. Now, am I as good at drawing this as your book is? No, I'm not. So let me show you what the book looks like for this one. So on this one, you have a plane going through the corner of the cube. So for you, this is the part that you're supposed to visualize. The part that you want to draw is going to be the actual segments where that plane intersects your cube. And then you look and see, okay, what shape is that I get where this plane intersects the cube? Well, if I draw 2 squares, connect them to make my cube, and then I know that my plane intersects here and here. If I were to connect those, it would be like this. And so I end up with a rectangle again. Okay, now what if there are different shapes that we can get from our cross sections? Like, for example, if we had a pyramid. Depending on which direction you have your plane go through your pyramid, you're going to get a different shape. So I'm going to start by drawing a square pyramid. To do that, I start with a square. In your book, it probably makes your square look a little bit more like a rhombus, which perspective-wise, might look a little bit better than my pyramid, but there we go. There's my pyramid. A lot of times in 3D drawings, if you will do the back lines dashed, it helps with the perspective some. Also, it makes it less messy because you end up having quite a few lines. Now, if I were to take a plane and put it through vertically through my pyramid, what I would end up with are lines that intersected on the two faces, right? So I have the faces coming down, and then I have the base. So I end up with a triangle. However, if I were to take a plane and intersect my pyramid going parallel to the base, anywhere along that pyramid, I'm going to get just a smaller version of that base. I'm going to get another square. Okay, a cone intersected by a plane that's parallel to the base is just going to give you a smaller circle, right? A sphere intersected by a plane is also going to be a circle. We'll be getting more into spheres later on in this chapter. Okay, now rotating two-dimensional shapes. Rotating two-dimensional shapes. The way this works is you imagine that you have a line and a shape, and then you need to visualize, okay, what would it look like if I were to take this and spin it around, if I were to rotate it around the line? Well, in this case, if I take a rectangle and rotate it around a line vertically, I get a vertical cylinder, right? Now, what if I were to take a circle and I rotate that around a line? Well, there's going to be some empty space in the middle, which is going to be my donut hole, and then I'm going to have a tube going all the way around the axis that I'm rotating around. So you end up with a donut shape. Okay, that is the lesson for this. So for your homework, the different types of things that you'll need to do, you're going to need to be able to use Euler's formula to find your faces, edges, and vertices. Sometimes it will be verbally done, sometimes it'll be in a list. You need to be able to describe cross sections if you're given a three-dimensional figure and a plane. And then you're also going to need to imagine, if it isn't drawn for you, what it would look like to have different cross sections that go through different three-dimensional figures, and tell me what those shapes would be. How many sides would they have? What would they be? Okay. This one's an interesting one. Thinking about planes intersecting cubes. And then you will need to practice rotating around some axes. Notice they're asking you to do horizontal instead of vertical. So that is 14.1. Stay tuned for 14.2.